In a world where technology advances at the speed of light, some discoveries redefine the very nature of reality. In 2025, the Nobel Prize in Physics recognized one such breakthrough, one that bridges the mysterious world of quantum mechanics and our everyday experience. This is the story of the scientists who dared to explore the unthinkable, who revealed quantum effects in the world we can see, touch, and manipulate. Their work has opened new frontiers in computation, medicine, and our understanding of the universe. Quantum mechanics, developed in the early 20th century, describes the behavior of particles on a tiny scale. Electrons, atoms, and photons follow rules that seem almost magical compared to the classical physics of planets and pendulums. For decades, quantum phenomena were thought to be limited to the microscopic world, too fragile, too fleeting, to observe directly in larger systems. But in the 1980s, three pioneering scientists, John Clark, Michel Dvorak, and John Martinis, challenged that assumption. They demonstrated that quantum effects could manifest in macroscopic systems, paving the way for quantum technologies. Their experiments explored superconducting circuits, delicate devices where electric currents flow without resistance. Here, the strange rules of quantum mechanics became visible in ways never seen before. At the heart of their work was a device called the Josephson junction. Imagine two superconductors separated by a thin insulating barrier. On paper, electrons should never cross this gap, but thanks to quantum tunneling, they do. Through painstaking experiments, Clark, Dvorak, and Martinis observed quantum tunneling on a macroscopic scale. They also demonstrated energy quantization, where a system can only occupy certain discrete energy levels. These discoveries weren't just theoretical triumphs. They revealed that quantum states could be controlled, measured, and manipulated in ways previously thought impossible. Suddenly, the dream of a quantum computer, a device that harnesses the power of quantum states, was within reach. The impact of their work rippled far beyond the lab. Superconducting qubits, the building blocks of many modern quantum computers, rely directly on their discoveries. Today, quantum computers are solving problems once considered intractable, from complex simulations to cryptography. But the applications don't stop at computing. The precision measurement techniques born from this research enhance technologies like MRI machines, enabling doctors to see inside the human body with unprecedented clarity. Clark, Dvorak, and Martinis turned abstract theory into practical innovation. They showed that understanding the universe on its smallest scales could revolutionize our everyday lives. In October 2025, their decades of groundbreaking work were formally recognized. The Royal Swedish Academy of Sciences awarded the Nobel Prize in Physics to John Clark, Michel Dvorak, and John Martinis for their discovery of macroscopic quantum tunneling and energy quantization in an electric circuit. The award celebrated not only their scientific achievements but also their dedication, curiosity, and perseverance. Their journey reminds us that science thrives on bold questions and careful experimentation. As Clark himself reflected, it was an unexpected honor, but it underscores the importance of our work. The journey from quantum theory to real-world technology is only beginning. Thanks to the vision of these scientists, we now inhabit a world where quantum phenomena are no longer confined to theory. They shape the devices we use, the medicines we rely on, and the understanding we have of our universe. The discoveries of 2025 remind us that the smallest particles can have the biggest impact, and that curiosity, creativity, and courage are the forces that drive science forward.